Hello everyone, welcome to the 7th lesson for topic 4.2 loans, investment and annuities. So this is the last lesson for this topic already. So I'm not going to go through the learning outcome because it's exactly the same with what we have done in lesson 6. So I'm going to explain what are we going to do by doing a quick review for everything that we have learned so far under topic 4.2. Let's start off with the recap. Alright, so there are a total of 6 lessons that we have done under this topic. So this is the 7th lesson, right? So in our first lesson, we talk about the difference between the simple interest and also the compound interest. So I hope that you still remember. So for simple interest, we talk about the interest is generated or calculated based on the principal that you are having only. So compound interest is based on the principal that you are having plus the interest that you accumulated throughout the previous period. All right, so that's the difference between them. So that's why if you are an investor, then you know that if you are looking for like an investment scheme, then of course compound interest is going to give you more interest compared to a simple one, because you can imagine that you are earning interest throughout the period that you are investing, right? So that's why the total account is becoming bigger and bigger. So if let's say you are using simple interest, then the interest is only generated from what you have put inside the account in the beginning only, but compound interest will give you will give you a higher interest because the interest here is generated based on both principal and also the interest that you accumulated. All right, so when we talk about loans, investment, and annuity, no matter which account that we are looking at, basically we are using the calculation for compound interest. All right, okay, then after that in lesson B, we talk about what is that meant by the effective annual rate of interest. So we knew that for compound interest, right? Sorry, let me finish my effective annual rate of interest. All right, so we know that in compound interest, there are actually two things that is going to affect how much interest that we are going to earn throughout our investment. So the two things is, the first one is how high is your interest rate. So of course, if you compare to 7% per annum and 8% per annum, then 8% is going to give you a higher one. But on the other hand, we also have something that's called the compounding period, right? So which means that if let's say you are having two different schemes with both 7% of the interest rate, but one compounded annually and the other one compounded monthly, so at the end you'll realize that the interest that you get after a year is going to be different as well. All right, so we know that the more frequent that your interest is compounded, then the more interest that you are going to get. All right, but then we have some situation where it's very hard to justify. So for example, if let's say you have like 7.5%, maybe this is annually. Okay, then maybe in the other case you have like 7%, then which is like monthly. So in this case, you know that 7.5% is going to give more than 7%, but then compounded monthly is going to give more compared to annually. So that's why in this case, how are we going to find out the real rate of interest that actually going to give us the amount of money after a year? So that's why we are using the calculation for effective annual rate of interest to help us to compare the efficiency, or like what is the real rate of interest that generated from the investment scheme lah. All right, so then after that in lesson C, we talk about how are we using our finance calculator to help us to solve the question about compound interest. So that's the first time that you are introduced to the finance solver. So I hope that by this time you are actually quite familiar with this already. And for this lesson also, we talk about how do we use compound interest in depreciation as well. So there are three types of depreciation that you have learned last. So flat rate, reducing balance, and also the unit cost. All right, so it's basically how do you use your recurrence relation into depreciation only. So which means to investigate how the value of something changes, or like how the value of something reduces over the time. All right, then after that for lesson DEF, you are introduced to different accounts. So that's the main part. Yeah, I would say it's like the main part of this lesson, which we talk about. The first thing is the investment. All right, and then plus the regular deposit. Okay, so for lesson ABC, we only talk about the situation where you have one-off kind of thing. So the investment that we are talking about is like you putting a sum of money in the bank. Then after that, you didn't touch it at all. Then after that, for depreciation, is also about, I mean, uh you have you have something, then the value of something is where you started, right? Then after that, it just keep on depreciate. So that's why in DEF, we're talking about that small there's more flow of money happen in your account. So when we talk about investment, instead of like a one-off thing, you also put in regular deposit. Okay, then after that for E, then we talk about the loans as well. Okay, so for loans, and then you plus the regular repayment. Okay, then after that for lesson F, okay, which is where we stop, we talk about annuities, right? So for annuities, then it's something like a retirement scheme that you are trying to take out money regularly from your account after you retire. So this is regular withdrawal. All right, so you can see that the way that we are dealing with no matter which account here are actually just the same. So which is by using our first order linear recurrence relation. So the difference here is only the flow of money only. So like investment, you put in the money in the bank, regular deposit, you put in more money. Then after that, for loan, it's like you borrow money, then you repay back. Then annuity is like you put in money, then after some time, then you withdraw it, right? So that's the difference. The way of you are handling it should be the same. It's just the flow of money is different. So I hope that you can see the pattern over here already. Then under annuity, we also talk about something that is like a special kind of annuity, which we call as the perpetuity. Okay, so for perpetuity, you are having regular withdrawal also, but then the special thing about perpetuity is the withdrawal that you are withdrawing every time is basically equal to your interest. So that's why there's not going to be any change for your amount of perpetuity in your bank lah. All right, because you withdraw whatever that you have earned. So that's why your principal keep on to be the same. Then the interest that you get every after every period will be the same, and that's basically the amount that you withdraw. All right, so that's something that you can, yeah, I'm just going to go through here. Okay, so you realize that for investment and regular deposit, right, what happens through the account is that the money in your account is getting more and more. So you are putting more and more money, then more and more interest is generated as well. So that's why for this account, it's actually a growth, okay, which you do not have like a limit. So you can just keep on increasing as long as you have money, then you keep on deposit your money in the investment scheme, then you get more money, right? So you can go up to infinity. So for loan and annuity, so you can imagine that the money that you are trying to borrow, so after you repay, right? So the amount of money that you are owing actually decreasing. So at this point, so this is where that when it keep on decreasing, then money cannot be a negative value. So the minimum that you can reach is zero, right? So that's the end for your loan. So which means you paid off every of your loan already. So that's why you have something that is called like what is your last repayment. So same thing goes for annuity as well. So you keep on doing regular withdrawal, right? So that's why the amount of money that you have in your annuity account is decreasing as well, and it's going to reach zero. So that's why you have your last withdrawal in your annuities. So your annuities will just die after the account reach zero lah. So for perpetuity, then it's always the same. So that's why there's not going to be any growth or any decay. Okay, so yeah, that's basically the part. So that's why you see this topic is called as loans, investment, and annuities. So it's because of these are the main three accounts that we are looking at. All right, okay, then after that for today's lesson, we are going to talk about something that is like what is the special kind of situation that we are having in these three account lah. So the first one we are actually is like a further, it's like an advanced addition for annuity. So we are going to talk about indexing. Alright, so as what I mentioned previously in our lesson as well, so because of, you can imagine that because of inflation, so 10,000 now and 10,000 10 years later is going to be different. So that's why we are going to look at the situation where if let's say the withdrawal that we are having is increasing, then what happened to our annuity? Then the second thing is what I have mentioned throughout the lesson as well. So when we are dealing with lesson DEF, the situation that we are looking at, right, is the number of compounding and number of payment made per year is always the same. So when you try to key in your calculator, the finance over your CPY and PPY is always the same. But now we are going to look at the situation where how if the PPY and CPY is different. Alright, so that's basically two things that we are going to deal with today, and that's just the end for this topic already. Then you can start off with your own revision and so on. Then for next week, we are going to continue with our lesson for 4.3. Alright, so let's start with our lesson here by talking about indexing first. In lesson 5F, we investigate on annuity with regular payment or withdrawal. So if you can recall in the recurrence relation in annuity, we talk about after 1 year, then you will have, throughout the period of 1 year, you will have your interest generated. Then at the end of the year, you withdraw some amount of money, then the same pattern going on, right? So the payment that we are looking at are a regular one. So however, in real life situation, regular withdrawal might not be a very realistic option because we know that inflation happen over time. So which means that after you retire, if let's say you are planning for like 20 to use your to keep up your annuity account for 20 years, right? Then which mean that if let's say you are withdrawing 3,000 per month, so the 3,000 in the first year is not going to be the same with the 3,000 in the 10 year. You get what I mean, right? So that's why what are we trying to do here is that instead of doing a regular withdrawal, we are increasing the amount of money that we withdraw from the annuity account over the time. So please remember that we are doing this not because of we want to spend more or not because of there are something specific that we want to buy, so that's why we are taking out more money. We are doing this so that the money that we are having here, right, keeps up with the inflation, and also we can maintain our purchasing power. Alright, so basically because of we want to keep up with the increasing living expenses lah. So that's the idea. So in this case, we will say that when the withdrawal here are indexed. So that's why this is called as indexing. So this amount of money that we withdraw is changes over the time in line with the real situation. So now we are going to look at the exactly same situation with our previous lesson, which we talk about Sarah invests 500,000 in her superannuation account, which give 5% of per annum compounded annually. So she will withdraw 40,000 after 1 year and after every each year. So now instead of doing this regular withdrawal, what happen if she withdraw another additional 2% for each of the subsequent year? So which means in the first year, she withdraw 40K. In the second year, she withdraw additional 2% because of inflation. And for the next year, another 2% increase. Alright, so you can imagine that the withdrawal is going to increases over the year lah. Okay, so now same thing, we will try to understand it by using our timeline here. So this is T0. So it started off with 500K in our account, right? Right. So what happened here is for every year, you are going to earn 5% per annum. So plus 5% here. Then after that, withdraw 40K. Okay, then you reach the end of the first year. Then after that, throughout your second year, you are going to earn another 5%, but you are going to withdraw another 2%. So that's why it's going to be 40,000 multiplied by 1.02. Alright, because this is you are increasing 2% lah, so multiply 1.02, right? Then after that, the same thing is going to be 2% increment from what happened in your second year as well. So you plus 5%, okay? Then after that, minus off how much you are having here is going to be the same amount here, but you multiply one more 1.02. So 2 times of 1.02, so that's why multiply 1.02 square. Okay, I hope that you get what I'm doing here, yeah? So because you want to get 2% more than this, so multiply by 1.02. Another 2% more than this, so you're going to multiply another 1.02. So you can straight away do 1.02 square lah. So that's the idea here. So same thing, let's try to find all this value here. Then after that, we can try to write down our recurrence relation here. So in our first year, we have 500K and you get 5% of interest. So we have 525,000 in the bank. So we are going to withdraw 40K in the first year. All right, so after this withdrawal in our account, we still have 485,000. Okay, then moving onwards in the second year, so you are having this amount of money, right? So this amount of money is going to again generate another 5% of interest. So we have 509,250 in our account. All right, so the withdrawal here will be increasing for 2%. So that's why we are having 40K multiply 1.02. Okay, so in the second year, we are withdrawing 40,800. Okay, so the same thing, this amount of money minus off the withdrawal, and now in our account, we have $468,450. Okay, so same thing, the amount of money is going to give us 5% of interest again. Okay, so withdrawal another 2%, right? So instead of writing this amount of money multiply 1.02, we try to relate it to 40,000. So it's the 40,000. So, or you can remember that this is the previous amount of money that you withdraw, right? So you are going to add another 2%. So you are going to multiply 2 times, so square. So equal to 41616. Okay, so the amount of money after the withdrawal, we have 450,256.50. Okay, so that's the idea. So obviously, when you try to look at this sequence, right, when you compare to the previous one that we are having, definitely the one that with indexing, you are going to use up your money, I mean, in a shorter period. Reason being is, I think it's very obvious lah, because the money that you are withdrawing each year is increasing. So that's why the interest that you are earning is going to be increasing as well, because the money in your annuity is decreasing faster, right? So at the end of the day, I mean, with a low interest earn and also with more withdrawal that you are taking out, so that's why the account is going to last shorter when you try to compare to a normal one. Okay, so let's try to write our recursive rule here. So we can see that for this part, okay, I guess definitely there's no problem with this, because how you are finding your interest rate is always by using the previous value of money, then you multiply by 1.05, right? So I hope that everyone has no problem for this part yet. Okay, then 1.05 TN. Okay, so this is the part. So normally we just write 40K, right? But in this situation, you can see that the withdrawal here actually changed over the time. So instead of only writing for 40K, then what's the thing that we should address here? So you can realize here that for this case, right, when you are doing your first withdrawing, so in your T1, during your T1, the withdrawal that you are doing is 40K. During your T2, you multiply 1 time of 1.02. During your T3, you multiply 2 time of your 1.02. So in this case, I can actually write this, right, because 1.02 power 0, that's actually 1. So that's why when you are doing year 1, then it's like 0. When you are doing year 2, then you multiply 1 time. T3, then 2 times. So how should you relate it to the end here? So you can see that for this one, you multiply by your T0, multiply by your, okay, let me try to write down. To find your T1, you use 1.05 multiply T0, right? This is your T0. Okay, to find your T2, you use T1 multiply 1.05. To find your T3, you use your T2, which is your previous term, to multiply 1.05, right? So you can see that this value on the top, on the index for your interest rate increment in your withdrawal, right, is basically the same with the number of term that you are having here. So T0, so 0, T1, so 1, so T2, then is 2. So that's why if you are using Tn here, then which means it will be 40,000, then multiply by 1.0, and the n will just follow with the number of term that you are having here. Okay, I hope that is clear. So which means that you can imagine if you are doing T1, then which means T1 will be equal to 1.05 minus 40k multiply 1.02 power 0, which is correct to what we want here. If you are finding T2, then it will be 2. So T2, then which means n plus 1 equals to 2, right? So your n here is 1. So T2 equals to 1.05 multiply T1, and then you minus off 40,000 multiply 1.02 power 1. So this is correct. So when you do T3, then which means 1.05 multiply T2, then you minus off a withdrawal here, which is 40,000 multiply 1.02. The n here is 2 lah. Alright, so this is how we are doing this. Then after that, also don't forget our T1 here, our T0. Okay, T0 will be equal to 50,000. Okay, so something must be bear in mind in our calculator solving is that for indexing, we can only do this by using our recursive rule. So you realize that in your finance solver, right, you can't actually change the payment. So the payment that occurs for every period should be the same. So that's why you can't do this with your finance solver. You only need to, you only can do this by using your recursive rule, and that's something that you need to be mindful of when you are using your calculator. So now we are going to look at the calculator part. Before that, let me just try to write this down first. Okay, so you know that when we are trying to put in our calculator by using the sequence generate, so when we are using the function of generate sequence in our calculator, right, we normally talk about the UN, right? So we are going to do the same thing. So remember that every time when you are doing UN, then which means at the back you will be using UN minus 1. So the same thing over here. If this become n minus 1, remember that your index should be n minus 1 as well. So 1.05 UN minus 1 minus 40,000 multiply 1.02 power n minus 1 also. I think it makes sense. So that's why, here is n plus 1. So that's why this is n. So if you are using un, then which means it should be n minus 1 and n minus 1. So something that very important about index is that for your initial term, you must use T1. You cannot use T0. Previously in our lesson DEF, right, we talk about the situation where the initial term, you just put in your T0, then you remember that the numbering in your left-hand side is going to be 1 more than the number of term that you want. But then inside your generate sequence, because later the n that you are going to, how the calculator is going to help us to run the sequence is going to depending on your n as well. So that's why if you are putting your T0, then the n here will be having some misalignment, and that's going to make your answer different. So that's why for initial term, you only can do your T1. So instead of putting 500k as your initial term must be 485000. Alright, so I'm going to show you the other way of pressing this as well by using the, every time when I show you spreadsheet, I show you two-way, right? So one is by putting the formula you use like A1, B1 kind of thing. So yeah, I'm going to show you that, so that is very useful in this situation, so you are not confusing with yourself with this. The other one using generate sequence, but just remember that the initial term that you are using must be T1. Alright, so let's start with our calculator here before we move on to the example. Alright, so first one, let's try out with our generate sequence first. So this is the one that you are more familiar with. So menu, data, generate the sequence. Okay, so same thing. So remember to type in exactly the same. 1.05 multiply u n minus 1. Okay, minus, put in a bracket, 40,000 multiply 1.02 power n minus 1. Okay, then bracket 1 for n minus 1 and 1 for the 40,000. Alright, so reaching this step, I hope that you are alright. Okay, so 1.05 multiply un minus 1, then minus of 40,000 multiply 1.02 power n minus 1. So initial term here, so this is the important part. So remember, you must not use your T0. You must use your T1 only. So in this case, our T1 that after we calculated is 485,000. Alright, so again, you can go and try to think about like why you can't do it by writing down your sequence, then you'll be having a better idea on that part. Alright, but then later when we are trying to look at the example, I'll try to explain it again as well. Then you'll be able to see the exact sequence that you're having here. So 468,540, then 450,256 and so on. Alright, so this is correct. Okay, let me try to show you again if you are using, I'm just going to copy paste here. Okay, so if you are using your T1 as 50K, right, you will realize that the answer will be different. Okay, so you see the second value is different already, then which means the whole sequence here that you try to generate here is going to be wrong as well. Reason being is because of the n that you are using here is going to be different. So remember that when you are writing your T1 here, right, the calculator doesn't know that the n here that you mean is 0. They will just follow your calculator. So that's why when you are putting it as T1, then this is the value that they already using 40K multiply one time of 1.02 already. Because you see, this is even though your T0 in your own sequence, but in my calculator, in our calculator, this is our T1, right? So if you are using the previous value multiply 1.05, then minus of 40,000 multiply 1.02, then that will be power 1 already, which is not what we want. We still want power 0 for us to get the first value here because you didn't start to increase your 2% yet. So that's why that's the case that will make your sequence a little bit different. So that's why just remember that if you are using generate sequence, then make sure that the initial term that you are putting at when you are doing indexing, it should be equals to T1. Alright, so the other way that you can try to do it is the calculator. Okay, so if let's say I'm using, let me try to do it here. Okay, maybe I can just cancel first. Okay, so I'll be putting the value here 0, 1, 2, 3, 4. So if you want to continue to add it, then you can just highlight the whole thing, then menu data fill out. Okay, so in this case, I'm just going to show you the fill value here. So if let's say you want to use the formula method, what you can do is you try to key in your 0, 1, 2, 3, 4. Okay, so make sure that you should be having this column here. Okay, then after that, as you continue, then this will be your T0, right? So that's why 500K. So when you move on, how do you get your next value? You are using your 1.05 multiply with the previous value, which is C1, right? Then minus of the 40,000. Okay, multiply 1.02 to the power of, the first time you are still doing 0, right? Because you only want to minus off 40,000. So you see, to find our T1 is 1.02 power 0. So that's why we are using B1. So that's why power B1. Alright, then after that, close it, then enter. You should be able to get the exactly same value that you have as your T1 here. Then when you're here, then just highlight the menu data fill. Now just go down. Then you should be able to get the exactly same thing like what you will be having here. 2, all right, then 3, 3, 4, 4. So this is the alternative lah. So for indexing question, I will really encourage you to find out the first few term so that after you generate it with your calculator, you can check and see whether your answer is wrong or correct. Okay, because you doesn't want to you doesn't want to have that experience where the idea of you are doing the sequence is correct, but you key in your calculator wrongly because of I mean, yeah, because of some careless mistake or something like that. Alright, so that's the calculator part. So remember, finance solver, we can't use it when we are doing indexing. So now let's try to look at one more simple example to just practice one more time for our calculator. Then after that, we move on to the second part for PPY and CPY. Alright, example. A person wishes to deposit 200,000 into an account that will earn interest of 8% per annum compounded annually, withdrawing to 25,000 at the end of the first year, 25,500 at the end of second year, then continue on. So each annual withdrawal being a 2% increase on the withdrawal of the previous year. So what is the balance of the account immediately after the fifth withdrawal? Alright, so in this case, I would say that for the cases that involving indexing, then it will be good that you can try to write down the first few term. So it's for your own checking as well, and I believe that it's actually harder for you to straight away write down your equation based on the information here. But if let's say you can, then please go ahead for that. Okay, so I'm doing in a way where if let's say you find it difficult, then you can try to write down the first few term. So first thing, if you want to write down the timeline, then you can also imagine what happened here is, okay, maybe you can try to just write down the term. So what happened in T0 when you first started off, you have 2,000 and 200,000. All right, then after that, at the end of the first year, okay, so or like after the first withdrawal lah. So after the first withdrawal, you are having the amount of money that you earn your first 8% of interest, right? So first 8%. Then after that, you minus off 25,000. Then you get your value of money at the end of the first year. So at the end for the second year, again, you are going to get 1.08, okay, multiply with the previous amount of money that you are having here. Okay, then after that, multiply your T1 lah. So if you want to write, okay, then it will be minus of your 2,500. Okay, multiply, that's the first time you increase 2% for your withdrawal. So same thing, moving onwards for T3, it will be your 1.08, then multiply your T2. So minus of 2,500, multiply 2 times of 1.02 already. Alright, so that's the idea. So after you have write down like this few term, you should be able to see the pattern, then you should be able to write it down. So if you are using Tn plus 1, okay, it will be equal to, so every time you are multiplying 1.08 with the previous term, right? So if we are finding Tn plus 1, then our previous term is Tn, okay, minus of, then 25000, you can see the repeating number, then multiply 1.02. So if you have nothing here, basically here is like 1.02 power 0. Okay, and that just give you 1 lah. So the idea here is that you didn't multiply any, or you multiply 1, you get back to the original value. So you can see that this is your T0, then you write 0, T1 is 1 time, T2, then multiply 2 times. So that's why you will follow your and here. Okay, so this is your recursive rule. And don't forget your T0 here. So in this case, you can write your T0, but just make sure when you are using your calculator, if you are using the generate sequence, then make sure that you should put in your Tn. Make sure that you need to put in your T1. So obviously the other one that you want to get, if you want to use Tn also can, then it's the same thing lah. So 1.08 and Tn minus 1 minus of 25000 multiply 1.02. So the power here will become n minus 1 also. Okay, so now let's try to key in all this in our calculator. All right. Okay, so we are here. Generate the sequence. Okay, so we can get 1.08 multiply un minus 1. Okay, and then minus of 25000 multiply 1.02 to the power of n minus 1. Okay, so initial term, so you might need to calculate it with your scientific calculator. If let's say you do not want it, then you can straight away calculate here. So multiply your 200,000 Okay, 200,000, then minus off your first 25,000. Then okay, so you should be able to get all this value here, so make sure that you are checking it. So after you find this, then I'll encourage you to just find out. So press this in your initial with your scientific calculator, then press this in your scientific calculator and check whether you get it correctly for the first three. So if let's say the first three is correct, then the rest should be no problem already. So alternatively, so you can try to use the method, so 0 0 1 2 3 4. So in this case, later we are going to find out what is the how long will the balance in the account will be reduced to 0. So in this case, we might need to continue this. All right, so you just highlight everything that you are having here. Then after that, menu. Okay, if you're not sure how to highlight, so remember here, then you press shift. Then after that, you just go down. Okay, so sorry, control. I think I can't do it by using my cursor here. So you can try out yourself. You press the shift, then after that you just go down. Okay. Then after that, menu, data, fill. Then just go down. Okay, until the roughly until 30, I think that's enough. Okay, then after that you go back again. So you can write down our T0 here, which is our 20,000. Okay, 200,000. Okay, so how do you get your T1? You use 1.08 to multiply our F1, then minus of 25,000 multiply 1.02 to the power of, you are using this value, right? So that's why E1. Okay, then just press enter. You should be able to get the exactly same value here. All right, then moving onward, same thing, menu, data, fill, then just go down. All right, then scroll until you get negative, then that should be enough already. Then can just move on lah. Okay, another thing, if let's say you, I hope that you realize this by yourself already lah. So if you realize you can't read the whole thing, or you can see that because it show your formula here, and if you want to read the value here, then sometimes when you go to here, then you can see that, you just, drag the bar so that it become, or what you can try to do is you just, adjust the width of your column. So by having this, then you can look at the value in a much more clearer way. If let's say a calculator didn't give you more value, you can try to change it here. Okay, then document setting. So make sure that you change here. So the display digit. So if you want like 2-digit, the calculator will show 2-digit, so you can always try to change it here. All right. Okay, so yeah, that's the idea. So the question one is to find out what's the balance of the account immediately after the fifth withdrawal. Okay, so after the fifth withdrawal, which means at the end of the fifth year lah, so 1 year you withdraw one time, right? So after the fifth withdrawal, which means that at the end of the fifth year. So that's why you are finding your T5. Okay, so let's check our calculator. So it's either your T5 here, 141679, or it's your T5 here. So it's the same thing lah. All right, so write down our answer, 141679.25. So that's our answer. Okay, so now move on to part B. How long will it take for the balance in the account to reduce to 0, and what is the final withdrawal? So same thing, we try to find out when the sequence go to a negative value. So of course, you try to look at here, or you try to look at here, it should be the same lah. So you can see that T11, you still have positive amount of money. Then after that, go to T13, then starting to have negative value. So which means you're already withdrawing the money, extra money from the account already. So that's why T11, it will be equal to 12,884.17914. Okay, then for T12, you are writing more decimal places because later you want to calculate the final repayment. So 17,169.44424. Okay, so by looking at this, so which means at the end of year 11, you still have some money. So at the end of year 12, you are withdrawing more money already. So that's why the account will become 0 at the 12th year. So it takes 12 years. Okay, so how can you find out your last withdrawal? So you know that at the end of the 11th year, you are still having that amount of money, right? So this amount of money is going to still give you 8% of interest for the 12th year. So that's why using this value multiplied by 1.08, then that's the final withdrawal that you can make. Okay, so yeah, I mean, you are not, so you can imagine that at the at the end of the 12th year after interest is generated, you have this amount of money only, right? So that's why you can't afford to withdraw like around like 20k already. So that's why this is the value of money that you left in your account, then you just take out the remaining last. So this is the last withdrawal. Or else if let's say you try to check, then what you can try to do is normally when we try to do loan, right, you can take like the last value, the normal repayment, then you minus off with the negative value. Or if you are dealing with annuity, then you can use like the not the regular withdrawal, then you minus off. But in this case we are talking about indexing, so you might want to remember that for your at your 11th year. All right, so what is the what is that called? What is the amount of money that you are actually withdrawing after you do indexing? So that's the idea. So you need to get 25000 to multiply 1.02 to the power of 11. Okay, let me try to write this out. So initially, yeah, that's right. Okay, so you can see that for your T1, you are withdrawing 25000 multiply 1.02 to the power of 0. So you can imagine that if you are calculating the withdrawal for the 12th time, then that will be 25000 multiply 1.02 to the power of 11, right? So, second time, you increase the first time for 2%. The third time, then you increase 2%, another 2%, the second time of your 2%. So that's why 12th time, then which means you increase like for 11 times already. So multiply 1.02 to the power of 11. Then you minus off the negative value that you are having here. Okay, then after that, you should be able to get the exactly same answer here. So again, I will always encourage you to go for the first method here. So the second method here is good for your own checking lah. So sometimes, when you get your answer, then you might feeling like you are a bit unsure. So you can try to do this again as your own draft to check that if let's say you get the same value, then that should be no problem with your answer. But in this case, remember also the withdrawal here, you must know how much, after how many indexing, then what is the withdrawal that exactly happened supposed to happen at the 12th year, but you don't have enough money to do that. So this is the money that you should withdraw if your account still having the enough money. Okay, so that's why you use this amount to minus off this, you'll be able to get the exactly same answer. Alright, so that's the part for indexing. I hope that you can answer them. So if let's say you got any question, then feel free to approach me personally as well. Then now we are looking at the last part, which we talk about the unequal CPY and PPY. Alright, now we are in the second part of our lesson here, which we talk about the frequency of payment is not the same with the frequency of compounding. So far in all the cases that we have been dealing with, the CPY and PPY have been the same. So now we'll be considering the situation where you have different frequency for payments and also compounding. So of course, for this thing, you can use finance solver to do this. So if you ask me, then yeah, you are much encouraged to use your finance solver to solve this kind of question instead of like using recurrence relation, especially in our second situation here. Okay, so same thing, we are going to understand the idea by using the timeline, then by using this table, then we just solve one very simple question at the end of each situation here, because the thing that you are using is just the same. So it's just that the recurrence relation and the finance solver, we are going to do it together lah. All right, and I believe that you should be able to solve all the question already. Okay, so situation one. So when we say that the PPY is CPY is not the same, then which means we will be having two different situations. So first, this is the first situation that we are looking at will be our CPY is going to be greater than our PPY. So that's why you can see that the interest compounding occurs more frequently compared to the payment made. So CPY is more than the PPY. Second situation later is for the part where payment occurs more frequently than the compounding. So which means the PPY here, okay, is more than the CPY. So that's the two situations that we are going to deal with them separately. Okay, so let's look at situation one first. So suppose that 250,000 is invested into an account paying 8% of interest compounded quarterly. Okay, so that's why your CPY is 4 times per year. So 40K withdrawn from the account at the end for the first year and at the end for every year thereafter. Alright, so same thing. If we are trying to show what happened here by using a timeline, then you can see that we have T0 over here, which we have 250K. All right. So moving onwards, then you can see that this interest is compounded quarterly. So first thing that we need to do is divide by 4 first, right? So 8% interest annually. Maybe I should put in here. Yeah, so this is 8% per annum interest. Okay, I'll try to add in your handout, no worries about that. Yeah, just to make sure that the 8% is per annum, not quarterly. Okay, so 8% per annum, which means for each quarter we have 2%. Am I right? So that's why you can imagine that what happened throughout the year is you will be having like 2% compounded. Okay, then after that, after one quarter, then compounded 2% as well. After another quarter, compounded 2% as well. Then after that, the other 2%. So that's why it's like quarter one, quarter two, quarter three, and then quarter four, and that's the end for 1 year lor, right? Then after that, at the end of the 1 year, you are going to withdraw 40,000. Alright, so this is basically what is going to happen. So you can imagine that interest will be compounded 4 times before one withdrawal is made. Let me rephrase my word. So which means that you are the account here is going to have their interest compounded 4 times before one withdrawal is made. So you can see you add up 2%, 2%, 2%, 2%, then after that you withdraw 40K one time. Then the same thing is going to happen for the other year as well. So for each quarter, you are going to compound 2%, 2%, 2%, 2%. Then after that, at the end for 1 year, you are going to withdraw 40K. So that's the idea for each of the situation here. Okay, so by looking at this thing, then I hope that you see the pattern and it's actually not very hard. Okay, so for the first year, so in this case, we are still going to look at it from the situation from a year, because you are going to include the part for withdrawal is happening, right? So that's why you can imagine that what is the total interest that you earn throughout the year. So for after 1 quarter, you are going to multiply 1.02. After another quarter, the amount of money that you are having over here is going to multiply another 1.02, another 1.02, another 1.02, right? So that's why at the end of 1 year, you actually multiply 1.02 for 4 times. Alright, so 1 time after the first interest, 2nd time after the 2nd interest, 3rd time, and 4th time. So that's why the total money that you are having in your account is going to be 250,000 multiplied 1.02 to the power 4. Okay, so after doing this, then you know that after 1 year in your account now, you have 270,608.04. So definitely when you try to do this, when you try to compare to the value that you straight away use 250,000 multiply 1.08, that answer will be different because the compounding period is different, right? I hope that I still remember the idea for the effective rate of interest. So that's the thing. Okay, so after the interest is generated throughout the year, then you withdraw 1 time, which is 40,000. So the amount of money that you are having minus off the withdrawal, then now in your account you have 230,608.04. That's easy. So the same thing happened for the 2nd year. So this amount of money, okay, is going to generate 4 times 2% of interest throughout the year as well. So from here, then we can get 249,617.56. So the withdrawal here will be the same, which is 40,000. Then after that, in our account, after withdrawal, we left with 209,617.56. Okay, so moving on, same thing for the third year. So we have 209,617.56 multiply 1.02 power 4. So 226,896.79. Alright, so same thing, withdrawal 40,000 is made. So at the account, we left with 186,896.79. Alright, so that's the value that we are having. So now based on the information that we are having here, now you can always see the pattern already. So you are using your previous term, multiply 1.02 to the power of 4, then minus off the withdrawal, right? So when we try to write down in our recursive rule, then it will be n plus 1 term will be equal to 1.02 to the power of 4. It's always power 4, right? So no worries about that. Then multiply our Tn, so minus of 40,000. Alright, so that's no matter you have bracket or not, they means the same thing lah, because multiplication comes before subtraction. Okay, so T0 is equal to 250,000. So for this thing, it's not so complicated as, when you try to key in your calculator, it's not so complicated as the indexing because you do not have any power involving, and so although you are having the power here, but then it's always power 4. So that's why you can still use your T0 in your calculator. So we are just going to do one simple thing here. So determine the balance of the account after the 6th withdrawal. Okay. So for each year, you withdraw one time. So if you are finding the 6th withdrawal, which means that we are finding T6. So first thing, let's try out with our recursive rule first. So if we are using our recursive rule, then we can just use the function for generate sequence lah. Okay, let me try to go here a bit. Okay, so menu, data, generate sequence. So just type in the equation here. So 1.02 to the power of 4. Okay, you might want to put in bracket. Oops, sorry. Okay, multiply un minus 1. Okay, because the recurrence relation we are using Tn plus 1, so Tn. So this is un, so un minus 1. Then multiply already, then minus of 40,000. Okay, so you can start with T0, that's okay. Okay, because we are not dealing with any n as our index. So after you're having this, then this is the amount of money that you're having. So since we are having some value here, so please try to check through that the value that we are having is exactly the same. Okay, so you know your answer is correct, but of course this is going to be T0 lah. Okay, so T0, T1, T2, T3, T4, T5, and T6. So after the 6th withdrawal, then it will be our T6. So 106,866. Alright, so that's the balance of our account after the 6th withdrawal. Alright, so if let's say you want to use the, oops, sorry for that. If let's say you want to use the key in also can, it's the same thing lah. So 0, 1, 2, 3, 4, 5, 6, 7. Okay, so starting from here, 250,000. Okay, of course in this case you don't want to put the 0 also can, it's just the same thing. So how do you find the next value? You are using 1.02, okay, to the power of 4, multiply with your previous value here, right? Then after, which is your J1, then after that minus 40,000. Okay, then just press enter, then you should be able to get the exactly same thing. So menu, data, fill, then just go down lah. You should be able to get everything correctly as well. Alright, so that's the idea how you should do it. Okay, so if let's say we are using our CS Finance solver, how can you do that? So same thing, the N. So how many payment is made? So remember, because our CPY and PPY is different already, so make sure that your N always referring to number of payment. So if you are looking at your calculator, right? So let's try to open another page. Okay, so menu, then go to your finance solver. So you can see that for your N here, it stands for number of payment. So that's why remember that although the interest in this case, right? So it happens like per quarterly. So the sixth withdrawal actually will give you one withdrawal is 1 year. So that's why it's like 24 interest is generated already. But the N in our calculator always referring to the number of payment. So which means how much withdrawal that you have done so far. So what is the balance of account after the sixth withdrawal? So number of payment is 6. Then I here 8%. So remember per annum year. Then after that our PV, the money is saved in the bank. So negative 250,000. Okay, moving onwards, our PMT. Okay, regularly we take out 40,000. Okay, so this is the part. So remember PPY is payment per year. So we know that for each year you only withdraw one time. CPY, the interest here is compounded 4 times per year because quarterly. So that's why there's some changes over here. Then you are just finding out what is your PV. So let's try to key in all our information here. 8% PV negative 250,000, PMT 40,000. So FD is what we want to find. So remember 1 and then after that 4. Okay, so remember if you are changing your PPY, normally CPY will change together. So you must make sure that the 1, 4 is correct. Then just tap everything, go back to FV, then you should be able to get the exactly same value as what we have found here. Alright, so that's the two method. Of course, if you were to ask me which one is easier, the question didn't ask you to use recurrence relation to do, then always goes for finance solver if you have a choice there. Alright, so that's our situation 1, and now let's look at situation 2. Alright, so for situation 2, we are going to look at the part where the PPY here is more than the CPY. Alright, so payment occurs more frequently than the compounding. So this situation is going to be slightly complicated when we compare to the previous one, because of the idea for how interest is compounded. Okay, so after you look at the situation, you'll understand why. So suppose that 250,000 is invested into an account paying 8%, same thing per annum interest here. So the interest here is compounded annually, so CPY is 1. So 10,000 is withdrawn quarterly from the account, so that's why your PPY is 4 times per year. Okay, so now let's try to imagine what's going to happen here. So this is our T0. So that's why we have 250K. Okay, so for every quarter, 10,000 is withdrawn, right? So that's why I can imagine throughout the year, you have first quarter minus of 10K. After another quarter, you minus off 10K. After another quarter, you minus another 10K. Then after that, last another 10K. Okay, so we know that the interest is going to generated here, right, for the 8%. Okay, so the problem here is when you're trying to adding the 8% here, so we say that the interest here is compounded. Okay, it's a compound interest throughout the year. Am I right? So you see, right, by using this idea, how should this 8% should be calculated? So you see, because you have this amount of money, if let's say the 8% is charged on this amount of money, then which means that the bank is kind of like losing some money because actually during the year you already withdraw some money. You actually didn't keep this money for a annual period. You get what I mean, right? So that's why you can see the 8% cannot be generated on this original value. So same thing, after 10K is withdrawn, then is it fair if let's say the 8% is calculated on this value? Not right, because initially you also save this amount of money for quarterly. Then you can imagine for every quarter the number change as well. So that's why how compound interest is calculated, right? Is that the interest is always compounded over the year. So which means it's like a accumulated kind of thing, which is like if you keep the money for the whole period here, then you get the 8% of interest. So you realize that in this case, right, it will be much difficult for us to calculate the interest generated here because of the money in your account keep on changing. So that's why what we need to do here is we need to find out what is the quarterly multiplication factor. We need to find what is the quarterly multiplication factor. So we want to match the period so that at the end of the day, it produces an annual compounding of 8%. Okay, so you can imagine normally what we try to do is we use 25000 multiply 1.08, you get this number, right? So which means that we want to find out what is the amount that we should multiply for 1, 2, 3, 4, because that's going to be where the value in our account change, right? So you are going to use this value compound 4 times, and at the end you are getting a annual compounding of 8%, which is 1.08. I hope it makes sense for you. So which means what's the value that we should multiply? So at the end, after you compound for 4 times, you get back to 1.08. So how do we get x? So we move the 4 to the other side, then it will give us a root of 4, then 1.08. So no worries, we are going to use the exact value here, but if you want to know what's the number, then this will be a number. Okay, so which means that you can imagine at this part, after I use the value that I'm having here to multiply this value, then I get a certain amount. So this is like 1.019. I'll multiply 4 times. I multiply back itself for 4 times, and I get back to 1.08, which is correct in terms of like how interest is compounded over the year. Okay, so now by looking at this situation, then you can imagine that we can't do this for yearly, because the withdrawal here is not like one off 40,000. Because if you do one off 40,000, then you do one off 8%, then it will be the case where your CPY and PPY is all equals to 1. But then you can imagine that if let's say your PPY now is like 4 times, right, then which means that the interest that you are getting compared to the 1.08% will actually be lesser than that, because the amount of your money in your bank, right, is actually reducing throughout the years also. So that's the idea. So that's why when we are doing this, instead of year, so I purposely put it here because I want you to cancel yourself to realize that if let's say you have this situation, then we can only do quarter. Alright, so now when we are trying to solve this, then which means that this amount of money is going to give us the interest of 0.019 blah blah blah. So when we continue, then it will be multiply the root of 4, 1.08. Okay, so by using your calculator, scientific calculator, you should be able to get the value. Okay, so withdrawal, you take 10,000, right? Then after that, you'll be able to get 244.856.64. So same thing for the second quarter, you are going to have this amount of money. Okay, multiplying the interest generated as well, which is root of 4, 1.08 as well. So we get 249,613.36. Again, we draw another 10K. So in our account, we left with 239,613.36. So moving forward for the third quarter, then you have this amount of money. Okay, so by looking at this, right, I hope that you can see the idea where you can try out in your calculator. So when you are doing 4th time, you multiply 1 time, right? So you can imagine that you are multiplying the root of 4 for 1.08 for 4 times already. So that's why when you are trying to do this in your calculator, you multiply itself for 4 times, which is power 4, then you get back to 1.08. So that's why you are still doing an annual interest of 8%, but it's just in an idea where, because withdrawal happen throughout the year, so that's why you do not have like a specific value that you can straight away charge the 8% of interest. So that's why we need to split this into the part where in a way where you can try to do it like quarterly for every changes that happen in your account lah. So that's the idea for what we are doing here. Okay, then 10K, and then 234,268.22. Okay, so when we are trying to write this in our recursive rule, you can see every time it's the same. You multiply by root of 4 for 1.08, then after that you withdraw 10,000. So that's why our n plus 1 term will be equal to root of 1.08 multiplied by our Tn, then minus of the 10,000. Okay, so I hope that is actually not very difficult here. But of course, just bear in mind in this situation where I mean, so far in all the past year question, right, if let's say it involve this kind of situation, normally they will just ask you to use your finance solver to do that. So far, we never have any question that they want you to solve this kind of situation by using recursive rule, because it will be kind of slightly more complicated lah. So what is more important is that, of course, to use finance solver if let's say you have a choice, but it will good that you understand how this thing works as well. Alright, so same thing, we just solve one simple question here. So find the balance of the account after 3 years. Okay, so first thing, let's try to use our recurrence relation first. Okay, so menu, generate sequence. Okay, so this is the part where how should you press this in your calculator. Okay, so you can go to this one. I hope that you see this. All right, so you press this, then the calculator will give you this, then you just choose one. All right, so this is what we want, then we just enter. You realize that it come out with like a root, something like this. So how should you press this? So you should press two numbers. So one number that you're having is like the number outside and the number inside. So we are putting the root of 1.08, and what's the power of root is 4. So 1.08 then comma 4. All right, then multiply with un minus 1 and then minus of our 10,000. Okay, then after that T1, our initial term here, we use our T0 lah, because we not involve anything with n in our index as well. Okay, so just tap, and after that you should be able to get this. So you should realize that going through all this number with the number that we are having in our table just now, it should be all the same. All right, so 244, 239, and so on. Alright, so that's the value. Then alternatively, of course, you can try to use generate your formula as well. So 0, 1, 2, 3, 4. Okay, so same thing. 0, we started off with 250000. So how do you get this value? So we are using, okay, our first value here equal to, we are using this value, okay, our M1 to multiply. Okay, multiply. So same thing here, you press this, then come up with this. Okay, so maybe in your calculator they will show you root or show you something like this, and just type in a 4. Okay, then after that you just tap, then go inside, then 1.08. So after you get this value, then minus off with 110,000. Alright, then you just press enter. Then you should be able to get the exact same value. Then after that, go to this cell, then menu, data, fill, then just go down and fill everything lah. Okay, then we should be able to get the exactly same answer. Okay, so let's try to write down our answer here. So the balance of the account after 3 years. So remember 3 years. So what we are trying to do in our calculator here, remember, is quarter year. Okay, because how do you get to all this? This is by quarter, this is not year. So Tn is the balance at the end of quarter, at the end of the end quarter. So that's why after 3 years, which means after how many quarters? So 3 years, 1 year, you have 4 quarters, so 12 quarter. So you are looking at T12. Alright, so we can try to refer to this. Okay, so T7, 8, 9, 10, 11, 12. Okay, so that should be this value. So same thing, remember we started off with T0, so the number that we are having here is one more than the number that we are finding. So what's that again? So T12, okay, will be equal to 181,238.78. Alright, so that's the value that we are having. Okay, so now move on. If let's say we are using finance solver, so same thing N. So remember N is number of payment. So now your payment is quarterly. So which means 1 year you withdraw 4 times. So after 3 years, which means that 3 times 4 lor. So your number of payment will be 12 times after 3 years. Then after that, the I here is 8%. PV, same thing, negative 250,000. Okay, so our payment here, every time you withdraw for 10,000. Okay, CPY, okay, the interest compound 1 time per year. Your payment is made 4 times per year. So CPY is 1, PPY is 4. Then we're finding our PV. So same thing, let's key in this in our finance solver. Alright, so 12, 8, negative 2500, which is the same. This is 10,000. Okay, we are finding our FV, then CPY, PPY, payment 4 times per year, then this is 1. Okay, then just tap, go to FV, then I should be able to get the exact same value. Alright, all good. Okay, now we write down our answer. So 181,238.7. Alright, so that's basically the end for this topic. So again, for the part for different CPY and PPY, normally you will be able to use finance solver to solve it, but you also need to know, I mean, for a better purpose for your own understanding as well. So try to understand how the recurrence works as well by using the timeline, then you should be able to solve all this. Alright, then after this, you can try to approach to like your exam style question by looking at the past year paper as well. So yeah, that's something that you can try to do. So yeah, we'll be having we will be having our consultation hour again on Monday. So if let's say you've got any question, feel free to attend. Then we are going to do some question together as well. So I'll see you on next Monday. So spend some time to finish off your homework. Alright, thank you.